All right, so we're going to finish up Chapter 7 by talking about the natural base E. All right, so just to clarify here, E is not a letter or a variable. E is a number, okay, just like pi is a number or I is an imaginary number. E is also a number. And if you take a look at your calculator, all right, you have a little e right here, and you also have one right here that says e to the x. So both of those, okay, are the actual letter number e, okay? And you're also going to need to be familiar with this ln button. That is called a natural log. All of the properties that we learned about in 7-4 that apply to the regular log also apply to natural logs. So you're going to kind of have a double taste of solving for those. So what you need to know is that the number e and a natural log are inverses. So anytime that you have them stuck together like this, they cancel out. Okay? So ln and e are going to cancel, and that just leaves you with negative 2t. All right, e is always raised to something. So this would be e to the ln of t minus 1. So e and ln cancel, and the answer is t minus 1. All right, number 3 is just a little bit different, though. All right, number 3, e is not exactly raised directly to the ln, and that poses a problem. You have this 5 that's stuck out in front. So remember that property that says if I take the log of something that has a power, I can move the power to the front? Well, the same thing applies. You can go backwards. I can move that power back to the exponent. So I can make this e to the ln x to the 5th. All right, so instead of moving it in front, I'm taking it from the front and putting it back as an exponent. That leaves me with e and ln next to each other. They cancel because they're inverses, and my answer is x to the 5th. All right, so that's how you recognize an inverse, okay? Kind of like on 7-4, you had several of those where the bases were the same. It's kind of the same principle. All right, so let's talk about how to solve natural logs. Well, here's the thing. They work exactly the same as a regular log. All right, only thing is you're not going to have a base down here, okay? Natural logs, you don't have like a base of 4 or a base of 5. All right, when you're adding, you're still going to multiply your non-base, okay? So you're still going to multiply the 5 and the x and condense it down into one log. So this is going to be ln of 5 times x equals 1. All right? Now that I have one log, all right, down by itself, I need to get rid of the natural log. The only thing that cancels out a natural log is if you take e and raise it to that natural log. Then they're inverses and they cancel. So I'm going to take an e, and I'll just say e both sides. So I take e and I raise it to the left-hand side. But what I do to one side, I have to do to the other side. So I'm going to take an e and I'm going to raise it to the power of 1. This e and this natural log cancel. And now I'm left with 5x equals e to the first, which is just e. To solve for x, I divide by 5. So x is equal to e over 5. All right? I am fine with you leaving it just like that. Since e is a number, that you don't need to do anything else with it. You can leave it. Now, if I plug it into my calculator, it will do it because e is, let me just throw that up there. E is 2.718281828, blah, 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 blah. Okay? So if I say e divided by 5, e over 5, I'm going to get a number. It's just going to be a decimal. All right, so this would be about 0.54 if I were going to round it. Okay, I just want you to leave it like this. Okay, there's no reason for a decimal if you can have an exact answer. All right, but just so you know, that is there. All right, so let's take a look at number 5 over here. I have 2 natural logs that I am subtracting, and when you subtract, just like with a regular log, you will divide the first non-base by the second non-base to condense it down into one log. So I'll have natural log of 5 divided by x equals 3. To get rid of the natural log, I have to take e and raise it to both sides. So this would be e to the ln of 5 over x is equal to e to the third. You can't forget you have to do it to both sides. So the e and the ln are going to cancel, leaving me with 5 over x is equal to e to the third. Now I just have a simple algebra 1 problem. I have to solve for x. Well, we can't ever solve for x if it's in the denominator, so we have to get it off the bottom. So since I'm dividing by x, I will multiply by x. That leaves me with 5 equals e to the third times x. Well, I'm trying to get x isolated or by itself. Since I'm multiplying x by e to the third, I will divide by e to the third, both sides, so they will cancel, and I get x is equal to 5 divided by e to the third. Like I said, e is a number, so I don't want you to give me a decimal. I just want you to leave it like that. If you did divide it, you would get 0.25. All right? All right, number 6 is going to be a little bit different. I only have one natural log. All right, so you want to kind of treat this ln x as like the variable that you're solving for. Okay, so you want to get this part by itself. So before I can e it, it has to be all alone. So if this were just a big x right here, the first thing you would do is you would add 2. So that leaves you with 2 natural log of x equals 0 plus 2, which is 2. And then if I still want this, it's being multiplied by 2, so I would divide by 2. So now I have ln x equals 2 divided by 2, which is 1. Now that my natural log is by itself, I need to e both sides. So I'll take e to the ln x equal to e to the first. E and the ln directly next to each other. Those cancel. That's the whole point of doing that, right? So I get x equals e to the first, which is just e. All right, remember e is a number, so we're not going to give a decimal for that. All right, number 7. I immediately notice that I already have an e raised to an ln, so those immediately cancel because they are inverses. So now I have x to the third equals 8. To get rid of a cube, you have to cube root. Now remember, you could plug that in your calculator, but you can also say what times itself 3 times equals 8. That would be 2 times 2 times 2, which is 2. Okay? If you do it in your calculator, remember that you need to choose math. This is a cubed root right here for option 4. And then all I have to do is put in 8, and it's going to tell me that that's 2. All right, so we're going to talk about a formula, all right, that's involved with the number e. All right, you have continuously compounded interest, okay? This is your formula right here. A equals P-E to the RT. A is the total amount. P is the principal. If you don't know what principal is the amount that you start with, okay? R is your annual interest rate, and you always put that as a decimal. So if it was 6% interest, it would be 0.06. And then T is time in years, or the length, okay? So it says, what is the total amount for an investment of $1,000 invested at 5% for 10 years, compounded continuously? So let's talk about this. They want the total amount, so we don't know what A is. All right, and remember the little formula is A equals P E to the RT. So there are 1, 2, 3, 4 unknowns. If you have 4 unknowns, you have to know at least 3 of them, all right, to figure your problem out. We want to know what the A is, right? So that's easy enough. P, the principal, is what we started out with. So we started with $1,000. So we plug that in for P. Then we've got the E. Remember, E is a number. All right. Then you're going to look at here for your rate. If the rate was 5% as a decimal, that would be 0.05 times the time, which is 10 years. So I plug in 10. And then all I have to do is plug that in my calculator just like it looks. So I've got 1,000 times E. Now I'm going to use this E because watch what happens. When I choose this one, it goes ahead and it puts a little box up here for me. If you use this one, you'll have to put your own box. Either way, it works out fine. And then in the box, you've got 0.05 times 10. All right, so I get about $1,648.72. So A is equal to $1,648.72. So let's talk about that means. It means I started out with $1,000 and it had 5% that was compounded continuously. All right, compounding, when you talk about loans and stuff, you can compound quarterly, yearly. This is continuously. All right. So after 10 years, I only made $648.72 because I started with $1,000. So that's not really all that great of an investment after 10 years. I mean, I guess I almost doubled my money, but not really. All right. So that would be my answer right there. Okay. So let's look at one more of those. What is the total amount? Okay, total amount. I don't know what that is. For an investment of $100, so my principal is 100, then we've got times E to the invested at a 3.5% rate. So if I moved my decimal spot 2 to the left, I'd have to fill that in with a 0. That'd be 0.035. That's how you figure decimal instead of a percent. For 10 years compounded continuously, so 10 years. And then all I do is plug that in directly into my calculator. So I've got $100, and then I've got to put in an E. E to the 0.035, and it is 10 years, correct? So times 10. And I get $141, and we'll round this. If we look at the 0 behind the 0, there's a 6, so if it's 5 or bigger, this rounds up to a 1. So this would be $141.91. So we've got $141.91. So you started with $100. After 10 years, you only made $41.92. You'd probably have better luck investing something else with your $100, or maybe just spending it. You know, I don't know. All right. So that's just a real life application of that. And I'm going to skip the last page because it talks about decay constants. All right. I'll show it to you. All right. We won't do this problem, but it talks about fossils and how paleontologists use natural bases to figure out how old something is over time. And that's it.